Okay, we are going to look at lesson 113 today. This is Saxon Algebra 2. We're looking at lesson 113. Okay, and lesson 113 is on logarithms and anti-logarithms. Okay, so something to think about as we get started with this is going to be exponents. All right, so as we think about exponents, think about the fact that if I have 2 raised to the 5th power times 2 raised to the 3rd power. Remember that I'm going to do that as 2 raised to the 5 plus 3, so that's going to be 2 to the 8th. That's how I'm going to handle it when I've got the same base and I multiply and I'm going to add the exponents. All right, if I had 2 to the 5th divided by 2 to the 3rd, okay, that's going to be 2 to the 5th minus 3. You could think about the fact that this would also come up here as 2 to the 5th, and this would come up here as 2 to the negative 3. All right, so we would be dealing with these two, and again, we would combine our exponents. So this is going to be 5 minus 3, so this will be 2 squared. And then finally, if we look at 2 to the 5th raised to the 3rd, with that, I'm going to multiply our exponents, and so that's going to be 2 to the 5th times 3, so this would be 2 to the 15th. All right, just a review of how we handle it when we have the same base and we're multiplying, we add the exponents. If we're dividing, we subtract the exponents. And if one power is raised to another power, then we would multiply the exponents. Okay, let's think about this question. If I want to say what exponent, it's going to be my abbreviation for exponent, what exponent do I need for 2 to become 8? What exponent do I need for 2 to become 8? My exponent is 3. 2 to the 3rd power is 8. Okay, what exponent do I need for 4 to become 64? It would be 3. 4 cubed is 64. All right, what exponent do I need for 10 to become 100? The exponent would be 2. 10 raised to the 2nd power is going to be 100. All right. As we look at this idea of logarithms, okay, we're going to look at these questions that I've asked. The first one we would write as log base 2 of 8 equals 3. All right. So this is saying log base 2 of 8. What does that equal? It equals 3, meaning what do I need to raise 2? What power does 2 need to be raised to in order to equal 8? The second one we would write as log base 4 of 64. So what power do we raise 4 to? What's the exponent that I would raise 4 to in order to get 64? The exponent would be 3. All right, and then finally, log base 10 of 100 is going to be 2. All right, so this right here, how many times do I need to multiply 2 to get 8? That's what I'm asking. How many times do I need to multiply 2 to get 8? I need to multiply it 3 times. All right. So one thing to note is that, I'll change this for you. Okay. Logarithms are exponents. All right. Logarithms are exponents. So when I solve a logarithm, what I'm getting is an exponent. All right. Here, the 3 is the exponent of 2. So 2 cubed equals 8. Okay. 4 cubed equals 64. and 10 squared equals 100. With each of these, my exponent is what I got when I solved the logarithm. Okay, hopefully that makes sense for you. All right, so looking at this, what we're going to think about, just a basic little pattern for you here, is looking at 2 cubed equals 8 as our pattern. We've got B, L equals N. All right, there's the base. This right here is the exponent, right? All right, and we're going to look here that these are all going to be, we've got this base right here of 2, we have this exponent of 3, and then it equals 8, that's number 8, okay? Here's my base, here's my exponent up there, and here's my number that it equals, okay? So then this is going to translate as log base 2 of 8 equals 3. All right, so thinking of that right there, you see how you can equate those? 2 cubed equals 8. 2 to what power equals 8? It's 3, okay? So you can see this idea how when I get this answer here, that is an exponent that I'm getting, all right? Okay, so I can say that log 10 of 100 equals 2. Log 10 of 1,000 equals 3. And log 10 of, oh, no, that's not where I was going. Log 5 of 125 equals 3. Okay, 5 cubed is 125. Log 2 of 32 is 5. In other words, I would take 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 equals 32. All right? Okay, so a logarithm tells us what the exponent is. All right, so looking here at this example that I'd given you up here, we can think about our b to the p equals n. So the base raised to some power equals some number. All right, so I can look at log base b of some number equals p. Good. This is a good thing to remember. This right here and this right here are good to remember. All right, so you just kind of, because you know how this over here works, you know 2 cubed equals 8. This is the same thing. I'm just, over here, we generally, in our standard form, what we're doing is we're solving for the number. We're generally solving for the 8. Over here, with the logarithm, we're solving for the exponent. All right, so it's just kind of twisting your brain around. You already know how to do it. You just have to look at it a little bit different. All right. Let's look at a couple of other ideas here. We want to make a note that the log base cannot be 0 because 0 to any positive power is 0. It also cannot be 1 because 1 to any power is 1. So the log base cannot equal 0 or 1. All right? We cannot have log base 0 of 3. That doesn't work because 0 raised to any positive number is going to be 0. I can't have log 1 of 3 because 1 raised to anything is going to be 1. So these do not work. All right? Okay. We want to look at, you're going to use your calculator by and large for solving these. We'll use that. So you want to get familiar with your calculator and how that works. Ideally, you do want to be able to do this on like a TI-84 or something like that, just because if you're going to go take the SAT or the ACT, you cannot use the calculator on your phone. So you want to be able to use another scientific calculator. The TI-84 is common. I think the TI-85 is also common, but don't hold me to that. Things are going to be just entered in different directions. If I wanted to find log base 10 of 105, all right, on my TI-84, my Texas Instruments 84, I would wind up hitting the log key, and then I would key in 105, and then I would hit the enter button. All right, and the answer that would give me is 2.0211899299, which means that I would need to raise 10 to this power over here in order to get 105. 10 raised to this power gives me 105. On my phone, I have a calculator, and it's just called Real Calculator. And with that phone calculator, I wind up typing in 105, and then I hit the log button, okay, and then I hit the equal sign, and it gives me 2.021, all right, and what this means is that 10 to the 2.021 equals 105. All right, so test that out on your calculator, see which way it has to work for you. Again, doing this on something other than your phone is what is best. All right, and then I want you to also try out doing log base 10 of 215. And I will tell you, your calculator is automatically set to give you the log base 10. So that's what we're going to work with on your calculator primarily at the moment. All right, so if you could key that into your calculator, and what you are looking to get is 2.332, meaning if I raise 10 to the 2.332, I should get 215, okay? All right, there is another logarithm that mathematicians use, and this is going to be called the natural log. So we're going to look at this. This is going to be the natural logarithm, natural. All right. The natural log is going to be represented by the letter E. All right, this equals approximately 2.71828188285, okay? On your calculator, you're going to find a little LN. That's going to be the key. All right, that key is the natural log key, so you want to look for that. All right, so if I've got this problem, log base E of 105. All right, what I'm looking to solve there, this is going to come out to 4.65396.035. Okay, remember with this is the exponent. All right, this is my base, and this is my number. All right, so that means basically that E raised to the 65396.035 is going to equal 105. All right. If I'm doing this on my regular calculator, with my calculator, I key 105, then I hit this log natural button, LN, and then I hit the equal sign, and it's going to go 4.6539, yada, 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 yada. Okay. If I'm using my Texas Instruments, I need to use that log natural key. Then I'm going to key in 105. And I actually have to key in an ending parenthesis because when I hit this log natural, it winds up starting in parentheses. So I put the finishing parenthesis and then I hit enter. Okay, and it's going to give me the 4.6539, etc., etc. Okay, and what that's telling me is E, which is 2.71828, etc. Okay, raised to the 4.6539, etc., equals 105. Okay? All right. So we're going to do a little bit of work with this now. All right. If I've got log 2 of 8, that's going to equal 3. All right. I also know that 2 cubed equals 8. All right. This 8 right here we call the antilogarithm. All right. That's the number we get when we raise the base to the log. The antilogarithm, the number we get when we raise the base to the log. So this right here is going to be that antilogarithm. That's the number that we're getting when we raise the base to the log. All right, so look at this. If I want to say find base 10 antilog of 4.316. What I'm saying is find the base 10 antilog of 4.316. So what I'm saying is I want to take 10, raise it to the 4.316, and find the antilog over here, which you know how to do that on your calculator. Raising 10 to the 4.316 is going to give you 20,701.41. Okay, you should try that out on your calculator. Make sure that that works for you. Okay, the way that we would wind up entering this in using a log, okay, here, this right here, I've been given the exponent when I look at this. I have the exponent. And what I'm wanting to do is if I know that the base is 10, and I have the exponent, then I'm wanting to find this antilog, and we would typically just take the 10, raise it to that. But we can also use an inverse log. All right, so with that, what I'm going to do is I'm going to key in 4.316. I'm going to hit the button that says INV, okay, and then I'm going to hit a button that says log. L-O-G, all right, and you know, this right here, this inverse log winds up basically being 10 to the x, okay, and then from those I hit enter and it's going to give me 20,701.41. This right here was on my calculator. Okay, if I'm doing it on the Texas Instruments, my TI, I'm going to have to hit this. There's a key up at the top called second. So I'm going to hit second. Then I'm going to hit log. Then I'm going to key in 4.316 and I will hit enter. Okay, and then when you do that, you should get this answer right up here. Okay. You should also be able to, just to kind of play around a little bit, say that I have log base 10 of 20701.41. If you enter that in, you should wind up getting this 4.316, okay? And I would have, to do this, I would hit the 20701.41 and then just hit your log button. And what you should get from that is the 4.316. So you can kind of see how you can kind of move these things around back and forth a little bit. If I key in 4.316, and then I hit my inverse log button. What you'll get out from that is 20701.41, telling you if this is the exponent, okay, this is what I'm going to get when I raise that exponent. When I'm raising 10 to this 4.316, I'm going to get this 20,701, okay? All right, let's look at some other ideas here. Let's find base E and to log 5. Okay, and so remember where that 5 is going to be, okay? Remember that, when I had the log base 2 of 8 equals 3, that this right here is the antilog. All right, so now I'm saying I've got base E. Okay, I'm wanting to find the antilog of 5. All right, so this 5 is my exponent. Okay, remember that idea? That's my exponent there. All right, so now what I'm going to do is I'm going to key in, I've got the 5. I'm going to do the inverse of the natural log, those two buttons. And when you hit the equal sign, you're going to get 1.48413. Okay, which is going to tell you that log base E 148.413 equals 5. Okay, I was trying to find this antilog. I was finding that number right there. All right. Okay, looking at a couple of notes that I have here for you. Just a couple of notes that I have in here, remember. All right, that, not this. Just a reminder that 2 raised to the 1 equals 2. 3 raised to the 1 equals 3. Anything raised to the power of 1 equals itself, right? Remember, if I have the log 2 of 8 equals 3, okay, then if I'm asking you for the antilog of 3 base 2 is going to be 8. The antilog of 3 base 2 equals 8. There's my antilog, okay? Just a little reminder there. If you just, an aside, that value of E, I told you that E equals this 2.718281828. If you're wanting to find that yourself, you can wind up taking, this is the idea that E raised to the power of 1 is also going to equal E, right? Just like up here. So if I take 1 and do the inverse log, okay, that's going to give me this 2.71828. Lots of numbers, right? Okay, so this right here is giving you what E is equal to. All right, because E raised to the power of 1 is E. Okay, so when I've got this log E, all right, and I'm wanting to find, if I've got my exponent is 1, what is the antilog? This right here is giving me what is the antilog, so that's telling me right there that's what the antilog is. So just so you know, this right here is what E equals. All right, and that's how you can prove that. Okay, we're going to do a little bit more work. I told you this is a long chapter. 113 winds up being a really long lesson here. So we're going to use these ideas to do a little bit of work here. All right, let's change things up for a moment. Okay. All right, let's see. We're going to use log base 10. Log base 10 solve. All right, we're going to use log base 10 to solve this. All right, so I've got 47,832 times 59,463 all over 0.000817. Okay. All right, we could do all of that math, right? But what we're going to do is we're going to use our log key instead to change all of these into 10 raised to something, and then we're just going to have to deal with the exponents. Okay, so if I look at for the 47,832, the log is going to be telling me that this is 10 raised to the 4.68. So you enter in this right here, you hit the log, you're going to get that number right there. Okay. If I look at the 59,463 and I find the log of that is going to be 10 raised to the 4.77. And then if I've got this 0.000817 log, this is going to be 10 to the negative 3.09. So now I can rewrite this problem up here as 10 to the 4.68, all right, times 10 to the 4.77 over 10 to the negative 3.09. All right, so what I'm going to wind up with then is 10 raised to the 4.68 plus 4.77. And then think about this, the 3.09, it's a negative down here. It's going to come up to the top as a positive. So now I'm actually going to just add this 3.09. All right, so then I find that this all equals 10 to the 12.54. You can just take and do 10 raised to the 12.54, or you can do the 12.54 inverse log. All right, and that's going to give you an answer that looks something like 3.47 times 10 to the 12th, because it's a big old hunkin' number. All right. Or you could have done, 10, and then you'd have a key that says x to the y, and then keyed in 12.54, and then that should also give you 3.47 times 10 to the 12th. All right, but that's how we can use this to actually do some work. Why do we want to be able to change these things like this? Why would we want to do it? So we can take any number and change it into an exponent, 10 raised to some exponent, and then we can just work with the exponents, and the math is a little simpler there. Okay, all right, let's do the same thing. Okay, looking at the same problem, but let's use base E. Okay, so if we use base E, we're going to use that log natural key. What we would find is we would have E to the 10.78 times E to the 10.99 over E to the negative 7.11. All right, so again, we're going to then just take E raised to the 10.78 plus 10.99 plus 7.11 is going to be E to the 28.88. All right, on your calculator, you're going to want to doing 28.88, and we're going to do that inverse log natural, two keys, equals 3.49 times 10 to the 12th. All right. And over here, yeah, look at this one right here. Base 10 was this. Base E is that. Okay. So we can do that either way. We can do it in the E. We can do it in the we can do it with the base 10, and our answers wind up pretty darn close there. All right, let's look real quick also. If negative 0.0325 equals log base E of y, find y. Okay, so what I'm looking to do is I'm looking to find that antilog, right? Okay, remember, go back to that idea that we know log base 2 of 8 equals 3, right? And we know that this right here is our log. We know this right here is our antilog. And we know that this right here is our base, right? Okay, so going with what we've got right here, this is we have that log E of y. That's so funny. It looks like log E of I equals negative 0.325. Okay, so kind of putting it in an order that you would want. This is telling us that E raised to the negative 0.325 equals y. All right, so what I'm doing, I'm looking to find this over here. Remember that this over here is my antilog, right? So I can wind up keying in this negative 0.0325. I think I lost a 0 over here. I did. There should be an extra 0 there. There should be an extra 0 there. All right, taking that, I'm going to do that inverse log natural because we're using E. And I'm going backwards to try and find my antilog, and this is going to give us 0.968, and that's what we're going to have for y. Okay. If you were doing this on a TI, remember, you're not going to use this inverse key, but you'd use a second key. So you'd start off on the TI hitting second, and then you'd hit that log natural. You would then enter in the negative 0.0325, and you'd hit enter, and then it would spit out the 0.968. Okay? All right, let's look at another one real quick. If y equals 4,302, find find log base y, and we also want to find the log natural base y. Okay, so we're going to do, this is going to be problem A. This over here is going to be problem B. Okay, so I've got the idea that y is going to equal this 4,302. All right, so if y equals 4,302, so I'm going to go 4,302, all right, here's my y down here, all right, so I'm going to do this and hit the log key. All right, excuse me, this y is not a base. I'm just finding the log of y. That got a little confusing. Okay, so find the log of y if y equals 4,302. So I'm finding the log, and this is going to be like basically log base 10 of 4,302. So this is what I'm going to enter into my calculator. And when I do this, I'm going to get 3.63. Okay, so what that's telling us is that 10 raised to the 3.63 equals 4,302. All right, let's look at the natural log of y. So then I'm going to want to key in this 4302, and I'm going to hit the log natural key, and I'm going to get 8.37. All right, so that's telling us that e raised to the 8.37 equals 4,302. Okay, so 10, if we're looking for this 4,302, we have to raise 10 to the 3.63. If we're using the natural log, that has to be raised to the 8.37 in order to get the same number. All right, so that's what we were asking here, is if y equals this, 4,302, find the log of y and find the natural log of y. All right, and those were pretty simple, just entering that number, hitting log, or entering that number and hitting the natural log. Okay, one more here for you guys to try. We want to find x. Find x, and I'm going to say that x equals log natural 0.0043. Okay. It's written a little backwards from what we normally think, but this is the log natural, the natural log of 0.0043 equals what? So I'm just going to key in 0.0043. I'm going to hit that natural log button right there, and I'm going to get negative 5.45. All right, which that just means that e raised to the negative 5.45 equals 0.0043. Okay? All right, one more, couldn't resist. The natural log of x equals 4.13. All right, so remember, now I'm trying to find the antilog. All right, I know that, this is e, so e raised to the 4.13 equals what? And this should be a negative 4.13. So I'm going to key in negative 4.13, inverse, natural log, hit equal, and I'm going to get 1.61 times 10 to the negative 2. Okay, so that's telling me that when e is raised to the negative 4.13, what I get is 1.61 times 10 to the negative 2. Okay? All right, that is lesson 113. Just work through it slowly. I know that it seems like a lot, and it is a lot, but it's really not at the same time because you're already familiar with exponents. So go back to the base that you know and just relate everything to that. Log base 2 of 8 equals 3, and it'll get you where you need to go. We'll see you later.